So let's continue with our discussions, whereby we started off with the geological cycle and rock formation. Rocks are classified according to their place in the geological cycle, and there are three major categories of rocks. You have what we call igneous rocks, we have what we call sedimentary rocks, and we have what we call metamorphic rocks. Igneous rocks, the word igneous rock is coming from ignition. So it basically means rocks formed in an environment where fire is involved. Then you have sedimentary rocks, called sedimentary rocks because they are made from sediments. Then you have metamorphic rocks, called metamorphic rocks because they are formed through a metamorphic process. So a metamorphic process must take place for such rocks to be formed. So now, if we look at this illustration here, we can clearly see that we have the recycling of materials from one form to the other, and there are processes involved in that. So let's, for argument's sake, it all starts in the earth interior with magma. Magma, because it's under pressure as a result of the convection current in the earth mantle, this magma would always try to find a loophole to escape that pressure. So this magma would, for example, escape through the earth crust and come on the earth surface through volcanic eruption, right? When this magma comes on the earth surface, it forms what we call extrusive igneous rocks. Extrusive igneous rocks, remember extrusive is related to the word external. But then you get to find that which solidifies within the earth interior. It does not erupt out. That is called intrusive igneous rock. So then what happens, so it may basically mean magma escaping from the earth interior, either solidifying within or reaching the earth surface. When it reaches the earth surface, it creates what is referred to as volcanic mountains. So these volcanic mountains would be created by magma which solidified. After an eruption, it would later solidify to form mountains. But then these mountains made up of igneous rocks would start breaking down, right? These mountains would start breaking down through a process we call weathering. Breaking down of rocks due to several reasons. One is exfoliation, or for example, water. Water can significantly contribute to weathering. There's basically a weathering process that water is responsible, and we call it freeze and thaw. The same is true with heat, whereby, for example, rocks are being subjected to different amount of temperature. So they would start contracting and expanding, and eventually they would start breaking down. So now this weathering, when small rock stratus starts breaking away, these weathered materials would be transported elsewhere. When they get transported elsewhere, eventually they will be deposited. They will be deposited either in basins, they will be deposited either at the ocean, or they will be deposited in hydrological streams and so forth. when they get deposited there, they start piling up. So you have, for example, a deep sand, for example, the Kalahari sand, or they would form something like a delta, or they would form something like sand dunes. Remember, sand dunes would be formed either by sand that was transported by water or by wind. So eventually, those sediments would start piling up on top of each other. So you have a lot of sediments piling up on top of each other. Eventually, when these sediments continue piling up on each other, they go through a process called rethification. So rethification is a process whereby sediments, which was basically loose sand particles, start getting cemented together by natural cement. Remember, we have said one of the most abundant elements in the soils is silicon. So silicon can act as a natural cement to stick all those small sediments together. So eventually, when sediments are stuck together, they form what is called sedimentary rocks. Now, later on, these sedimentary rocks are classified into different categories. You would realize when we deal with these more details, they are classified into different categories depended on the kind of sediments that made up such a sedimentary rock. So now, sedimentary rocks would form the likes of sandstone, siltstone, limestone, claystone, and the like, depending on the texture of the sediments that were eventually rethified to convert sediment to a sedimentary rock. So then later, when these sedimentary rocks come in place because of rethification, these sedimentary rocks would start piling up. When it starts piling up, you have pressure mounting. So eventually, this either because of maybe earth movement, it could be because of tectonic activities, such uplifting or tension within the rock, within the earth material. This, if they get subjected to a certain amount of heat and pressure, they start changing their structure to be able to convert back to not back, but to a different kind of rock, which we call metamorphic rock. So now, when metamorphic rocks are converted from sedimentary rocks, they change their chemical structures. That is the same as, for example, making a clay pot. So a clay pot, you converted sediments and you subjected them to a certain amount of heat to be able to change it, to be able to harden that clay pot such that you can now make, for example, a plate or a pot out of it. So it's the same here with metamorphic rocks. Pressure and the temperature plays an important role. But then eventually, if these rocks are converted to a much more higher temperature, they get recycled back in the earth mantle to become part of magma. Then when they become part of magma, eventually you would realize that this process would continue. So now, that can give you an indication of what is likely to happen and what are the kind of processes that are involved in. So you would have, for example, things like soil erosion taking place. You would have things like sedimentation taking place. You will have also the process such as uplifting and exposure taking place. For example, bringing either, for example, igneous rocks or sedimentary rocks on the earth surface, or you will have things like weathering taking place, breaking down rocks, or things like solidification, crystallization, and consolidation of rocks. So eventually you have that very important cycle basically very important cycle at the exposure. And that is part of the reason why we cannot use rocks to be able, for example, to tell how old the earth is, unlike meteorites, because the rocks that we have on the earth have been recycled from time to time along the rock cycle, and therefore it's very difficult to tell which of these would be the oldest rock on the earth's surface, because they have been recycled from time to time. So we would end here. We would continue again with the next topic. Thank you.